All right, in this episode of Throttle Stop Garage, we're going to have a look at how we can take some plastic Lego pieces and make a turbo header. Okay, so if you tuned in last time, you saw us make the merge collector, and now we've got to get along to making the rest of the turbo header. Now, I've made headers before, but only naturally aspirated ones. I've never made a turbo header before in my life, so we're going to be, again, continuing on with the 321 stainless steel pipe. So this pipe header, not a tube header, sorry about that last time, but we're going to move on. So I've designed these parts. Again, you'll recognize them. They're not dissimilar from the ones that you can buy, but I've designed these and I've 3D printed them because I'm doing this once. I'm not going to be in the business of making turbo headers. I have no idea why I would even take something like that on, but they simply clip together, not unlike Lego blocks. They do allow you to turn them to all the various angles. I've only made them in a couple of different angle varieties. So 45s, I've done a few 22s, and then I've done 12, 25, and 50 mil. So 1/2 inch, 1 inch, and 2 inch long straights in order to combine everything together. And with that, and a couple of jigs inside the car, we're going to try to get this turbo header built. The start of all of this is actually controlled by the location of the turbo. Now, in order to do that, I also 3D printed the turbo. So I've just made a rough model of the turbo. It's not, just dimensionally it's close, it's not perfect. And then I've added in a rotating element so I can figure out what my turbo clocking is as I'm getting going here. I've attached that turbo model to the merge collector, placed it inside my engine compartment, put the flange on the engine, and now I'm going to start positioning the turbo to try to get the best fitment of the turbo in what turns out to be a rather tight space. Like the length of that collector is the last, I've just got it sitting here roughly mocked up. It's smashing into my upright for my suspension. So just like everything else, we're going to have to make things work. Let's go. Let's get this thing going. Enough talk. Let's get to work. So as we get ready to start assembling the manifold, I've designed and 3D printed these elbows. Of course, they're meant to mimic other popular available in the marketplace pieces. I'm not going to pay $800 in order to buy some plastic parts. That seems a little bit expensive to me. So I have them in the 2 different radiuses. So we've got both a standard long radius weld L, and there's also a short radius weld L, just in case, well, I know we're going to need, maybe even need more of these as we go, the short radius ones. They're printed in ABS if you're interested, so they're pretty tough. It's 7 hours to print 6 of them. It's okay for onesies and twosies. Even getting them apart is quite difficult, but that's the idea. Like they snap together and lock in pretty tightly. All right, so let's clean up all the parts and start putting the Lego pieces together. You would not believe the hours that it took me in order to get these parts to work. So cut the insides, file around the outsides, and finally fiddle them around so that they actually worked. Don't forget to put all the parts on your car. So up the suspension goes and latch it in place. So get it all put in there. It's a major constraint. It needs to be there in order for this to work. Then we, once that's all attached up, off the hood comes, because I knew I was going to be just bashing my head against that the entire time. So might as well get the hood out of the way. Good thing it only weighs like 7 kilos. So it's really easy to get out of there. And then the inner fenders, they just have to go. There's no 2 ways about it. Why pretend? This is material that just needs to be removed from the car. There's no way to get a giant turbo into this thing with those inner fenders there. Now I've replaced the inner fenders on this car before, so I know where the welds are because I put them there. So out comes the grinder, and we just whistle that part right off. Well, with that all out of the way, I then attached a couple of bars just to the cylinder head and then mounted the plastic 3D printed turbo onto the merge collector. I'm just trying to get it leveled up and get a good sighting of where it might go. So I was able to move the bars around a little bit, try to keep everything nice and in the right place. Then the hood has to go back on. So back on the hood goes, just to make sure I've got ample fitment. I mean, we're putting a hot side of a turbo, and I don't want it too close to that carbon fiber hood. Now, it's a long way away from the hood, so no big deal. So I've started with runner number 3. It's going to be the constraint. So always start with the one that's going to be the tightest or the hardest one to fit. So I've got 3D printed parts that go into the port of the flange that's bolted onto the head. And then I have a corresponding part that fits up into the tube. So then I figured out kind of how many pieces these little Lego pipes I'm going to need in order to make it work. And then I rotated it around, got to get it away from the dog bone there on that upper control arm, and then just work it around. Really not a whole lot of science going on just yet, just roughly trying to fit these parts into their right places. It wasn't actually all that hard. Kind of fun work, actually, if it wasn't falling apart all the time and mostly breaking. All right, so we can now see the new way that I've done that. Hard to see because no light. Hold on. Every time. Okay, so with the little bit of tube work, I think I tried 2 or 3 different versions. You can see how quickly that happens. It doesn't take as long to do it. I'm just going to pull the fake compressor side off. Just to give you a little clearer look at what we're doing now. So again, I was concerned with tightness here in this area because it'll make the weld impossible. I wanted that loop around here to be a little bit nicer. And we've done, in the meantime, we've done the same or similar on the back side over here, which you can see. So we've straightened all of those weird and overly done angles where I swooped up and came back down. So now all that's left to do is mark it, tape it, turn it into something a little bit more solid. Again, these tubes are still able to pop out on me. You can see here right at the flange area there, it's kind of popped out. And we have to make sure that everything's going to stay together. So let's get that done. Okay, so as we're going along, the little bits of flex that I'm getting between the pipes and the collector, that's got to end. Okay, so I had planned for a more elaborate jig, and I guess I was just being lazy. So I have to take these the turbo off, and I'll show you what I'm going to do right now to settle it. The problem is every time I move this just a little bit, parts are falling out. And then you're going to end up with small gaps and other things in your fitment that just aren't quite right. And we can't really have that, right? So that's not going to work out long term. And overall, you end up with, tubes that have fallen off completely as we're in playing around with this stuff. So here's what we're going to do. This is the mating V-band flange to the one that's already on the collector. We just got a piece of 2.5-inch stainless steel tube, so I'm going to tack that into that. Then I'm going to add a muffler clamp to the whole mess, and that'll allow me to, of course, position this up and down where I need it. And then I've got some pieces of rod all prepped and ready to go, and I'll tack those on to make a securing jig that will take that merge collector. So we'll take the merge collector and we'll now attach it really firmly so that wherever it goes is where it goes, and we won't deal with the whole, floppiness of this. As you can see what'll happen. All right, so let's get that work done. Yeah, we're not in a great big race to get this done. We're more or less trying to just make our lives less miserable. So I got a new replacement lens for the 3350 Viking. And what you just saw me do there was put my cheater back in, because honestly, couldn't see at all what I was trying to weld right there. So you younger guys out there, just remember, when you get to be my age, you stop being able to see anything. And when you're TIG welding, well, it's going to get to be kind of important. So cheater is just a magnifying lens that we use to see stuff. All right, so bars are in, the pipe is on. The turbo's got to be level in order to drain properly, so I'm checking the level. Approximately level. It's never going to be, be as perfect as it can be. Then I'm getting it set up so that at least 3 of those tubes are going to work. And I did actually spend almost another full day getting the tubes sorted out after this. So strong advice, if you're doing this, let's get that collector put in firmly the first time. Okay, so with the new mount on here that is going to become the welding mount, I just have to secure the top part of that tube when I get it put over on the bench. But I think I went through about 4 iterations for almost every single tube in here after I already thought I was done. So what I thought was going to be a pretty simple job yesterday, just come out, mark the tubes, tape them up, and then fit them up, turned into a bit of an epic struggle. So we now have everything fit in there nicely, almost nicely, as I noticed the one tube is down. And then you can kind of see how that works, where you can take the tube, fit it into the collector, and then kind of push it home to find the angles. This one joint always pops out. This particular tube works better if I fit it into the collector first and then just sort of rotate it home. So that one's fine. Anyway, we'll get this all sorted out. Now I'll mark them and tape them. But just for interest's sake, this is sort of what it looks like when you're done. The field of broken dreams. Not 100% happy with the design. It seems like the ones I printed, well, I actually printed these quite a long time ago, but if I printed them with a fine nozzle and a small layer height, like, the finish is nice, but they end up being pretty fragile, where the ones that I printed with bigger nozzle and a lower height are pretty durable. So a 0.6 nozzle with a layer height of 0.3 is what those are in ABS. Again, discarded tubes. These little 1/2-inch ones turned into sort of single use, right? You can get them to snap home one time, and then half the time you break them, the 2 inches were just as bad. So you can see there that we are on average 11.1, so about 11 1/8 inches long for each one of the tubes, with a variation of about 3/4 of an inch total. It's not bad. It's about as good as I can make it. And the overall length ends up just a hair under 23 inches. And again, that should be to the turbine, and I'm not exactly sure where that is. And you know what? That's close enough. So we're going to need another chill block. So this one is going to serve for that manifold flange. When I ordered it from McMaster Carr, it's just a piece of 1-inch aluminum, 4 inches wide, 24 inches long. They're cutting it with the old handsaw trick. It was a little bit warped, but again, they're giving you a little bit extra on the width of the material to make sure that it's going to surface down to a 1-inch thick part.
And here's where that welding table, boy, does that ever come in handy. So quickly square up that flange, transfer those holes over, trace where the center of the ports go, and then we're going to mark the center of those ports and where they're going to outlet. And then I'm just going to drill and tap a few holes. So this is all pretty lickety split, like easy work, nothing stressful or hard about it. But I suppose you could, weld it to your bench if you're kind of crazy, but I don't mind actually spending, what did this take me, half a day, a little less, to drill and tap the holes, get this thing done, get it out, get it surfaced. I'm not in a big rush. I'd just rather have it done properly, to be honest. All right, so it's the center drill, and then for the last, just drilling the rest of the holes home. And then taps. Remember in one of my last videos I complained about taps? I bought all new taps, right? So I took some of that huge check that YouTube gives me, and went out and bought some brand new taps. I can literally get, that's an M8 tap. It's going in with one finger. So nice. As soon as you get it started, it's just nice and sharp, easy. Buy yourself some new taps. You've earned it.
So the plate's back in from the engine machine shop, so I'm going to take it apart and have a quick look as we get the rest of this jig made. Well, this razor sharp, that's for sure. I'll have to get that fixed up. You can see the finish. Of course, using the head surfacing machine instead of a mill with well, you could get a mill with a great big shell mill or something, you could get this done. But again, it's only an hour of labor, so it didn't really cost much to get this all flattened. It took there was again 15 thou worth of rock out of it, and it should now be dead flat. Let me get my straight edge.
Yeah, at the end of all that, I guess you get the idea that you have to go in and out about 1,000,000 times with each one of those tubes before you're actually happy with how the pipe actually fits into each one of the parts. And then you know what? I got it up on the bench and I kind of did it all again. Just little bits here and there. Especially tube number 3. Like runner number 3 was a problem. I couldn't see underneath it when I was putting it in. So I just wanted to straighten it out, make sure it was even between, in this case, runner 1 and runner 5. So once I had it all evened up, then it's the last part of the jig that needs to get made. So I actually kept some of the little cutoff pieces from when I made the welding table that you're seeing right now. And I'm using them to make jigs to fit up onto the welding table. So I'm kind of glad I didn't throw those out. With that cheater in the welding helmet, boy, it sure is easy to TIG weld again. Super happy that that's working. Anyway, shout out to Lincoln Electric for actually being able to warranty that for me.
Well, I'm getting closer to being finished, fiddling around with the various design elements. I think the tuned length for these is somewhere between 22 to 26 inches from the last calculations that I did in Pipe Max. So I think we can wrap it up there. Good enough. I am hoping it doesn't fall apart. Anyway, so there's the rest of the jig all welded up. I've just added some extra bracing here to make sure it's good and strong in all directions. And I think we're good. right? I'm happy with, I was able to straighten out runner 3 a little bit. That was important to me, and get everything else looking pretty good. So we're in. And that concludes, I think, what you need to know in order to get the first step of making a turbo manifold built, which is you've got to get the jigs done. There's just no other way around it. There's no shortcut. It doesn't make it easy. Again, a lot of folk on YouTube, I suppose, they just open boxes. Right here, something somebody magically created. Other people wonder why pipe manifolds might cost thousands of dollars. I hope I'm going to demystify part of that process for you. Okay, so in the next episode, we're going to get going cutting up the pieces of pipe and starting to fit them up and see if we can perfectly match the plastic pieces. And I know there's 1 or 2 tubes that need a little tweak here or there, and we'll show you how to get that done too. All right, so thanks for tuning in. Keep your stick on the ice. Good as an opener, and they come apart. Half the time they break, but they do come apart.